Introduction to lasers. So in this section, we will be learning what the acronym laser stands for, how lasers differentiate themselves from an IPL, and also we will cover the visibility or the range it operates at or in. Lasers stands for light amplification by the stimulated emission of radiation. In regards to the aspect of radiation, it is non-ionic. So compared to an X-ray that can cause cancer, lasers do not. These are the four things found inside a laser, and I am simplifying them using images. So the active medium is the heart of the laser. The energy source is what tickles the heart. So if there is no energy source, there is no laser. The resonator consists of two mirrors, one fully reflective, 100%, and the other partially reflective, wherein it allows the light to pass 5% of the time. Lastly is the delivery system. It is how the beam exits. Typically, an articulating arm is used, shown here, and also fiber optic handpieces, which uses glass. And for ophthalmic purposes, they use a LIO, also called a laser indirect ophthalmoscope. These are the three main properties that set it apart. One is a single color per wavelength called monochromatic or monochromaticity is the property. The next property of laser is when the waves flow in the same direction. So if they're going to the right, all right, left, all left. When you have these two waves flowing in the same direction, then you have an intense field of energy. When they clash, then it cancels the energy. Now we have collimation, or if it's collimated, it means you can focus the light. So if you fire it in far distances, you do not lose energy because it travels at the speed of light. For this discussion, let me clarify it with all of you. An IPL is not a laser. It uses a white light that gets filtered out by these cartridges, or depending on the color of the filter, it could be yellow, red, purple, and whatnot. It only allows a certain wavelength to pass through. So once again, it mimics a laser, but is far from being a laser. This table here shows you the operating range of different lasers used in medical applications. So it starts from the ultraviolet rays, which is the most intense, especially at close range. Then we have the intense visible light, wherein it can be seen, it can blind us, or these beams of light falling on the infrared. So think infrared of your remote control at the house. You press on the button, you can control the TV. It's an invisible rays. There's a detector at the end that picks up the signal. So if you block it, then it's not getting the signal. These are the most dangerous ones, the ones we cannot see, because it's hard for us to avoid. It falls on the infrared, to the medium infrared, to the far infrared, with the ending with a 10,600 nanometer CO2 laser wavelength. So to summarize, the visibility of operating visible lasers, it covers the ultraviolet field, the visible field, the near infrared, mid infrared, and far infrared. We'll just add on the far infrared there. And this is where the medical wavelengths fall. And here is a sample of the typical types of wavelengths that we are accustomed to. Starting with the visible light, we have the 532 KTP, the 755 alexandrite, and the 810 nanometer diode. Now, also to share, especially with infrared devices, we professionals have actual special tools to view the beam. So even though it's not visible to the naked eye, there is a way for us to see it. So, and that sums up this section. And now let's set we up for the quality, no, question and answer portion. Thank you very much and looking forward to your response.